Good day all. Today we're going to be looking at SOP and POS. So we normally represent our logic expression in these forms, though we don't normally say it whenever we are discussing it so far. But if you look at them, basically, no matter the problem given to you to reduce, it normally comes in either in any of these forms. So your SOP means sum of products, and your POS means product of sum. Okay. Now, when we say sum of product SOP, this is a product A, B, C, D, A, B, A, C, D. All these are all what? Products. All these are what? All products. So when we add each of them together, we form what we call sum of products. So if we are to add all of this is going to be A, B plus C, D plus what? A, C, D. Okay. Now another example. They are numerous, but I'll be solving with this other example. Another example can also be your A, B plus what? C. This is another example. You can also have A, C plus, like as much as you can think, as B, C. Not that you can think of. So all these are what you call what? Sum of products. All these are what? Sum of products. So you're having a product, or adding themselves up. You form your words, your SOP. Now for your POS on the other hand, you're now having product or sum of two variables. Let's say A plus B, B plus C, just like that. A plus B plus C. All these things are all what? Sums. Now when you multiply them, you get your product of sum. So in this case, we can be having something like A plus B multiplied by B of C multiplied by A plus B plus what? C. Now this is your what? POS. This is your what? POS. Now, okay. Another thing again, another example that we can give can also be, let's say, A plus B in brackets plus multiplied plus what? A plus C. This is another example. So another example will be A plus B multiplied by your what? B. So long there is a sum and a product. There's a sum and a product. It can now come in either sum of product or product of sum. So you have to know the one that's being given to you. So in this case, we are having a sum, we are having a product. So in the previous case where I just said A, C, this is just a product. We're just having only what? Multiplication. The same thing with this. A plus what? B. This is just a sum. This is just a sum. So we don't have any product in this one, so you cannot call it a product of sum or a sum of products, because it has to be having the two signs, both the product and the addition or the sum, this thing in it. Okay, so that's for an example. Now we are done with the examples. Now let us now go into the next thing that we have, which is what? Canonical form of our what? SOP and POS. So okay, now our canonical form, what it simply means is in each of our aim here is to make sure that if we are doing for our canonical SOP, start from canonical SOP, that's what I'm going to be talking about. Our aim here is to make that each of our products, each product should have the complete variables in the whole expression. So in this case, looking at this example, example here, we're having A, B plus what? C. So our aim here is to make sure that you'll be in each of the products, which this is a product. You can also call this a product. Now, in each of them, we're going to be having A, B, C, A, B, C in each of them. So we're going to have something like A, B, C plus A, B, C. This is our aim to kind of make each product to have what? A, B, C, A, B, C, A, B, C, A, B, C, A, B, C. It doesn't matter the way it will happen, but we want to see A, B, C in each of these products because this is an SOP. So in between them is a plus, in between them is a plus, in between them. But what we want to see in each of the products is what? A, B, C, A, B, C. So that's our canonical. Now, the way we did for SOP, how we are able to convert this guy to is proper. The answer I wrote here is not the actual answer. For you to convert it to is and proper canonical form, we're going to be multiplying each of these products by the variable that you don't have, and plus its complement. What I mean is this. So in this case, we're going to be having what? A, B. We don't have C in this product, so we're going to be having something like C plus C bar. We are adding C plus C bar to this one, and we're moving over to the next one. We're going to be having A plus A bar multiplying our B plus B bar, then multiplied by our what? Our C. This is for this one. Now, remember our law that says that when you're adding these to is and complement to give you what? 1. So we want at the end of the whole day, if this is to give us 1, this is to give us 1, we're going to be having this as an answer. But canonical is more like you expanding it, trying to make sure that each of them have what? A, B, C, D. Now from here we can simplify or solve further. When we solve further, we have A, B, C. This is AB multiplying C plus AB multiplying C bar. The next one, A. Okay, let us first of all do C times B and B bar. We're going to be having A plus A bar in brackets still, and then B C plus B bar C. Moving over to the next one, we're going to be having, this one still remains the same. Now the idea here is not to reduce to its lowest form. Instead, our idea here is to make sure that the ABC is in each of the products. So in this one, when we open bracket, we say we're having A, this is A times this. We're having A, B, C. A times this, we'll be having A, B bar C. This times this, will be having A bar B C. This times this, will be having A bar B bar C. So as you can see, each of them is now having what? A, B, C, A, B, C. So this is our aim in whether it's having complement or not. What we want to see is what? A, B, C in each of the products. So this and this are actually the same. If you want, you can try finding Islam with this truth table. The two of them are what? They are the same. They're actually what? The same. But this is this canonical form. Our aim is to have what? A, B, C in each of the products. So this also goes for in case if you are giving something like in this case, if you're having D, it also goes for it. What it means is that each of them is going to be having A, B, C, D for this one, A, B, C, D for this one, A, B, C, D for this one. So in this case, we don't have C, D. We're going to be introducing this to this and D of it square. That is D plus D complement to this. That's how you're going to solve for this product. Instead, you move over to this one. And at the end of the day, you still open your brackets to have it in this form. Now, before you conclude, you have to first of all check if there's any like term. Because if there's a like term, we can also simply just take one. Because as we remember, our A plus A is also going to give us what? A. So any like term, you cancel one and you go with one. So as you can see, if you've noticed, this and this is here. So you can also write this to be what? A, B, C plus A, B, C bar plus A, B bar C plus A bar B C plus A bar B bar C. Okay, so what we have gotten now is what is canonical form of this. This is it. Remember, our aim here is not to simplify, but to have A, B, C in each of them. This is why we're stopping at ABCs, because this is also having ABC. If we had D here, each of them will be having ABCD. That's for example in this case. If we have E, ABCDE, each of them will have it. So we want each of the products to have equal number of what variables. ABC, ABC. Okay. Now what we have gotten is now what we call this canonical form of this A, B plus C. This is it. So this and this are actually what the same, but this is its canonical form. Now, another thing again they might ask you to find concerning this canonical form is what you call your minterm. Now, ask you to get your what? Your minterm. Now, the idea here is that any place you see an alphabet without bar, call it what? 1. In place you see an alphabet with bar, call it what? 0. That is your minterm distance for you. Right? So when you do that, you'll be having, for this case, you'll be having this. If you have to convert this to binary form, remember, any place you see anything with bar, call it 0. Anything you see without bar, call it 1. So in this case, in this first product, we're going to be having 1 1 1. Over to the next one. Over to the next one, we're going to be having what? 1 1 0, because our C is having what? Bar. And another thing I also need to say is that let your canonical SOP be arranged in alphabetical order. Let it not be A, C, and B. Don't disarrange it. It should be A, B, C, D in that order. Now, over to the next one. Which is this product, we're going to be having 1 0 1. To the next one, we're going to be having 0 1 1. To the next one, 0 0 1. 0 0 1. So this is what we have gotten, what the minterm of this guy. Now, another thing again you can also do is also to convert it to its to represent it in its min form. Now this is 7 in decimal. Converting this binary, this 111, even from your truth table, this 111 to this thing. Remember how you do it is 0 1 2. Converting it to your decimal, you'll be having that is what is 7. So you're going to be having small m subscript 7. Here is going to be what? 6. M subscript 6. Here 5. M subscript what? 5. Here is 3. And this is 1. So at the end of the day, you then say that the sum of your A in brackets 7, start accounting it in the numerical order. Say 1, 3, 5, 6, and what 7. This number is our what subscripts. So this, when you're asked to find something in minterm, you have to solve to these points. This is equivalent to this, and this in this minterm is this. You grab? Now let us continue. Okay, so for our POS, we're still going to we're going to be taking an example. Let us use this guy over here, this one. This is the example we're making use of now. Remember, this example is not limited. You have numerous, like all these examples of the solving so far. You can classify them under SOP or POS. I'm not giving an instance here. So let's say we are giving a question like A plus B and what A plus what C. We're giving this kind of thing. So you are meant to know that this is what POS, because we are having sums in your brackets and they are multiplying each other. So you have to first of all open brackets. So those ones in the bracket are what? Some are adding up. So the product of sum. Product of what? Sum, as the name goes. So this is our sum. And we are now finding the product, which is the multiplication of the two of them. Now, for us to find the canonical form, this one also has its own special way. For that of SOP, we say we're going to be adding something like A plus A bar to we're going to be multiplying by what? A plus A bar to each of the products. In this time around, in each of the sum, we're going to be adding A times A bar. So what that means is, in this case, and remember, our aim here is to make each of the products to have A, B, C. In this case, we don't have D, so it's going to be what? A, B, C. So in this one, what we are missing here is just what? C. So we're going to be having A plus B plus C dot C bar, all multiplied by A plus B dot B bar plus what? C. Now what we just got now is canonical form, but we need to also what solve further. When we do that, we are going to be, now the law we're going to be making use of here is our distributive law, the one that says that when you are having A plus B C, this can also be written as what? A plus B times A plus C. This law is only applicable to Boolean and to logic expression. It doesn't go for ordinary algebra. It doesn't go for normal algebra. So our distributive law are actually two. This is the second one. The other one that we normally do use is that if you're having A multiplying B plus C, we then see that here is going to be what? A, B plus A what? C. Now this one works in both logic function and logic expression, and both in algebraic expression. But this doesn't work in algebraic expression. It is only unique to what? Logic. We made it clear in one of our video. So you can go further to you can refer back to the video if you want. So this is what we're going to be making use of here. So in this case, we're taking our A plus B to be just this A, and then this product is this guy. So we're going to be having something like A plus B plus C multiplied by A plus B plus C bar. don't even think much of it in case if this one, if, and I'm just saying this just for you to understand, but if your aim is just to grab the idea here, is just simply taking the first C, putting it in bracket, and the second one, putting it in bracket, nothing much. You're not doing any special thing. So in this case, there's also something also going to happen here. We're also going to be having the product of, something will also happen here. You have A, you take your first B and add it to your C, and then another one. So you're going to be taking the second one, which is one with the bar, and adding it to your words. Yes, this is how far we can go. But another thing again we need to do is remember this and this are what like terms. So we can actually join them together. Remember when we said that if we are having like terms, something like A dot A, just take one. So this is having, it doesn't have any bar, this one doesn't have any bar, but we're taking it as one. We can write this to be what? A plus B plus C, A plus B plus C bar, and A plus B bar plus what? C. So these two and these two are like, we took them together. And then for our max term, here, when A doesn't have bar, we call it what? 0. And when it does have bar, you call it what? 1. So it's the opposite of what your mean term is. Doing that, we're going to be having that this is going to be what? 0, 0, 0. This is going to be what? 0, 0, 1. And the next one is going to be what? 0, 1, 0. Right? Now, so we're going to be saying the multiple of the total multiple of our max term. Max term represented as big arm is now going to be this in decimal is what? 0. This in decimal 1. This in decimal we have what? 2. In one of our videos, we're going to be talking about converting this to what? Decimal, in case if you don't know how it works. So thank you for watching the video. Like, subscribe, and live a very good life. Stand, yeah, be the best version of yourself. See you in the next video. Bye.